name's Dan, and this video is a video about functions in Unreal Visual Scripting, sometimes called blueprints. It's part of a series of videos which are an introduction to the visual scripting in Unreal, and we've done a few things during this series, and now we've got to the point where we're going to do functions. This video is probably going to be a little bit longer than the others because there's quite a bit to go through, I'm afraid. Part of the reason it's going to be long is because I'm not assuming that you actually have a programming background. You might be coming to this completely without any concept of functions and what they are from programming. If you do have that background, then you will find this useful still, but it may go a little bit slow at times for you. So you make your choice, you speed up, you skip bits if you want to, whatever you want. Another thing that I'm going to be doing in this video is not just talking about what a function is and how you make a function and use a function, but also why. And one of the things that I try and do with these videos that's different to many of the videos that's on YouTube is to not just give you a series of steps to describe how to achieve one thing in particular, but to actually spend some time explaining the principles of what's happening and some of the ideas around you so that you can become a more versatile Unreal developer. The last thing I want to say before we get started is that there is a perpetual problem with teaching things in programming, and it seemed to be particularly applicable when you're talking about functions, which is that in order to really see the power of functions, you probably need to be in a more complex situation than the ones that I'm going to give you. Functions are particularly useful as your programs grow, but I don't want to be using a large situation for you to teach you. So it may seem at times that you can achieve, well, you can always achieve the same thing through different means, and it may be that you find that the example. A couple of examples that I use are maybe a little bit trivial at times. So apologies for that. That's a kind of perpetual thing in teaching. Trust me when I say that functions are a thing that are really useful, and it's really helpful for you to be able to understand them. So the first question is, what is a function? And put simply, it's a reusable subscript. So let's develop that by showing an example. We've got Unreal open here. Just let me quickly say this is a standard third-person template. I've got a few things that I've created here. There are some that have just been created for earlier videos that I'm not going to use. I've got a new thing called a patroller, which I'll be showing you in a little bit, and I've got a pad, and we've used these pads for various things in different videos in the past. And all I've got is in this on this pad at the moment is some behavior where when you stand on it, or when you stand on it, it toggles whether it's on or off. Let's show you what I mean. So here we are in here, and as you walk onto it, it turns pink. Pink means on, and then we stand on it again, it turns off. On, off. All right, so let's go to the script to have a look at what's going on there. This is inside the pad, and it's just on the event actor begin overlap events. I've got a variable that I'm using because I might want to actually have some other behaviors here or somewhere else that is dependent on whether this is on or not. So I'm getting it to remember whether it's on, regardless of what the texture is that's being used, or the material. So this is on variable. When you step on it, it toggles this, and you do a not, and you set it to here. I'm not going to kind of explain the Boolean maths about that too much. And then also what happens is that you, depending on whether you're on or off, you change the material. Just a quick word about that. I find it, I don't know if you can change materials just as material. I find it easier to have a material instance, because as you hover over here, material interface object reference, it doesn't actually say instance, but I create material instances. The easy way to do that is when you've got a material. So I've got here the material, which is the floor. There's the glowing material, which is pink. And then for each one, if you just right click and you do create material instance, and then I've given it my name. So these are the instances that I'm not going to explain in detail what this is, but it's a bit like classes and instances. It's something where you can change parameters for different instances of the material, but it also makes it easier to manipulate as a variable that you can pass around, or I have found so. Back into the script then. So we've got a script here which just does that functionality. And it would be better if the thing was switching on when you stand on and then switching off when you move off. And it's actually relatively easy to make that happen. We need the, let's zoom in. There we go. We need the end overlap and event actor end overlap. Watch out when you're trying to do these things because it's easy to confuse with assign on actor end overlap. That's not what you want. You always want the actual event actor end overlap. There we go. And we're going to use the same script stuff here. So I'm just going to highlight that and do copy, and then I'm going to move this around a bit so that I can then go paste, which is, so copy was Control-C, paste is Control-V, standard Windows copy and paste. And I'm just going to put that in there. So I've got the same functionality in two places. Let's see what happens. Obviously, live coding, there's always a chance that something's going to go wrong, but let's have a look. So now when we step on, it goes pink, that's right, and we step off, it stops being pink, and that's fine. And this is all very well and good. And as I said at the beginning, there are easy ways to achieve some of the things that I'm going to be demonstrating here. But what I'm going to do is I'm going to demonstrate doing the same thing using a function. So we go back into the pad, and so the first reason for using a function is that what happens if I want to make a change to this process here? If I want to change what texture it is when it's off, for example, I need to change it both here and here. That can go away. This is what's called an integrity issue, which is I might remember to change it in one place and not in the other, and you lead to the potential for logical errors by having the fact that I've got the same code twice in my script, and so when I update it and make any changes to it, I've got to make changes to it twice. Now, I will admit that there is actually a simpler way of doing this than using functions, which is to disconnect the whole of this and just take execution from here into here, so it's using the same bit of script. I freely admit that, so that might actually be a better way of doing it than using a function. But this video is about functions, and I've been scratching my head for a really good example that doesn't work by doing that. So I'm going to create a function. So here we're now into how we make a function. So over here on the left-hand side, we've got various things to do with the scripts that we've got. We've got the variables that we've got in our blueprint, and you can see here it's got a thing that says functions. It also says 20 overridable. I'm not going to go into the overridable functions, but if you remember, the blueprint that we've got has inherited from the actor blueprint, and the actor blueprint has got some function of its own, which we can use, and actually, if you know about these things, you can override them as well, but we're not going to go into that. We're just going to create a new function by clicking on the plus button there. It gives me a new function, and I'm going to call this trigger, because that's what we're doing. So I've got a function called trigger, and I'm going to zoom out again and go back to that script. So this opens a separate script pane, a panel window for that function, which is trigger here, and I can click back on event graph to get the stuff there. And what I'm going to do is I'm going to get all this functionality from there, and I'm just going to highlight it and then go Control X to cut it, and go into the trigger, and go Control V to paste it, and put that in there. Now this doesn't depend on anything else, so everything's just worked. It should have gone just clearly without any broken links in there. I'm going to go back to my event graph. So what we've done is we've taken that functionality and made it into a separate script, which is called function, which has got a name, and it has this purple box is the entry point for the function. You've seen that I pulled off there. So all functions have an entry point. Some of them also have an exit node as well, and we'll see that in a little bit later on in the video. So I'm going to go back to the event graph, and if I want to use a function, all I need to do is to drag and drop that function across from the left-hand side there, and it gives us this blue box, and we can put execution into it. Notice that it's got a parameter here, which is target, which is self. That's always going to happen when you create a function. It gets more complicated when you want targets that are not the same object that you've got, but we'll deal with those in a much less, a somewhat later video. Excuse me. And we were doing the same thing for both the begin overlap and the end overlap, so we can do that again by let's try without drag and drop. We should be able to just do let's pull across from here and then just type in trigger, and yes, it does appear call function trigger. Okay, so I'm going to compile. Hopefully this will show that this is doing exactly the same as it was before. Okay, yes, phew, thankfully. Okay, that's good. Right, this is reasonable and fair enough, and it's a reasonably good use of a function. However, I want to show you something that is a little problem to do with the way we're actually doing this trigger, which is we're assuming there is only one actor in the world that can possibly overlap this this pad. And what is going to happen if we have more than one actor? Well, the fact that I'm asking that question, I've kind of pre-prepared something that will cause this issue, which is this little thing I've called patroller. And hopefully when we run, we'll see that this is slowly moving. And this is set so that it will also trigger this pad because it's an actor. Okay, so that's fine. We might want more than one thing to be able to trigger the pad. But what happens if I'm on it and then the patroller comes over, it switches off? So what it's doing is it's toggling every time either an actor overlaps or leaves, ends leave. And this may be what we want as our functionality, but it's more likely we just want it to stay on while there's any number of actors on. Okay, so this is going to be some more coding. We're going to alter the way that we're dealing with this, and I'll show you how you can use an input in a function in the process. So back to our pad, and in fact back into our function. Now at the moment what we're doing is we know whether it's on or off by this boolean, but I'm going to add another variable which is going to be the count. So this is the count of actors, and at the moment it's zoom a bit on that. It automatically gives you the same type as the last variable that you created. So it's created it as a boolean, but I want it as an integer because I want to count these. Just ease that up there, integer, and I'm gonna. Do I need to make it publicly available? I'm not entirely sure. I'm going to compile that and then highlight that again. Why is that? It's giving me some strange stuff over on the other side. What is the default value? I think it's because there's some. I've got the advanced open, that's why. Count of actors 0, that's fine. So it's going to start with no actors on it. So what I need to do is I need to tell this function whether it's being triggered by an actor joining onto the pad or leaving. So I'm going to have a variable, an input variable, which will allow this. So when you highlight the start node, the beginning node, execution node of the function, you have the ability over here on the right-hand side to add inputs and outputs. So we'll see an output later, but I'm going to add an input to this. And I've got to just call this count. And that will also be an integer. And what we're actually going to do is we're going to use this function in two ways. So when something joins onto the pad, we're going to add 1 by using this count. When one leaves, we're going to add -1, and then keep an ongoing count of how many actors are on. And then we will test whether it's 0 or more, and if it's 0, then we will set our is on to false, and if it's more than 0, we'll set it to true. I hope you'll see what we mean as we go along. Now you'll notice when I zoom out that input has now been added as a pin on the execution node for the function, so we can use that to make a change to the count of actors. So we've got our count of actors here, and we're going to actually we want our old count. We're going to add the two together. So I'm going to do an add node, and then set the new count using a setter node, and then we're going to do that test. So if it's greater than 0, greater than 0, fine. So just greater than. If it's greater than 0, and we're going to set. I've just realised there's a little clever thing that I can do here, which is just to set the value of is on to be true. We want it to be true if that count is greater than 0. So I can just plug that straight in there, and that will set that to be is on if it's greater than 0 and off if it's not. And then we can leave the last little bit here, which is going to change the material if it's greater than 0, or if it needs to change it, basically. I'm just going to tidy this up a little bit, hopefully, and we're going to see if we can make this work. So we need to go back into the event graph here. We've now got these new triggers on which it count. So I'm going to, pins, parameters, I'm going to put that as 1 when an actor joins, and -1. So these have been called inputs. In other areas of programming, they might be called parameters, and occasionally they have the strange name arguments, but they're information that you can give to a function call, and this box is sometimes called, this node is sometimes called function call. Right, let's see if we can make this work. So go back into our map and play. Now I've been doing this live, as you know. There's on, off. Now I'm going to stand on there, and it's going to be on, and the ball goes across. It doesn't change anything because I'm stood on. I'm going to try and jump on whilst the ball's there and see if I can confuse it. It seems fine. I wonder what happens if I put more of these patrolling balls on. I'm not going to go that far to show that. So what we've done here then is I've shown you how to use an input to make some changes to what's going on inside the function. Functions with inputs are really, really useful. So that's the calling the function, and that's the actual function itself, trigger, and with this input. You can have more than one input, so if I highlight that, you can add inputs. I'm just going to get rid of that. And you can add outputs, and we'll see outputs very, very soon. So we've kind of seen the first reason why you might use a function. I said I would do why as well as how. And in this case, the reason is because we want to reuse this code. And it's the most common and the most, the strongest reason in general programming of all types of why you might use functions. In some languages, they're called different things, subroutines, methods, or even procedures, but they're called functions in Unreal. And one of the main uses is to encapsulate some of your behavior and then reuse it more than once. And if you're passing in parameters, you can get it to actually change its behavior depending on that. Sorry, passing in inputs, I should use that word. The second reason for using functions is for tidiness. So we're actually going to open up the patroller, which is that little ball that's going backwards and forwards. And you'll see in here that I've actually got, on event tick, it's going through two functions. And the two functions are, the first function is controlling which direction it's going in. And the second function is actually doing the movement. And if we double click on a node, we get the function graph coming up. And we're just going to have a little bit of a look at this. So let's zoom in this way. So this is adding the delta seconds, which is the amount of time the frame has taken. And it's just adding that to the counter and then checking against the counter limit. If it's hit the counter limit, it resets the counter down to 0, and it toggles a Boolean variable which is telling you which direction that you're going in. Now, I told you that I would show you outputs. Outputs are really easy as well. You can just add them on the right-hand side, and you can get your function to calculate things and pass information out on the right-hand side. On this occasion, I'm not actually doing that. All I'm doing is I'm passing the input back out, and that input is available not only from this pin, but also as a node. So if I right-click, I can go delta seconds and get delta seconds. So it's used as if it's a variable that you can get. And I'm just passing that out. And in some ways, this may seem completely pointless. Actually, I like doing this for when I'm chaining functions together that need the same information. So if we go to the move function, that also needs the delta seconds. And the move function's got some functionality that makes it add something to the Y, and it's just using this is going right to determine whether it's going left or right, and it adds it onto there. So if we go back to the event graph, we've chained them together, and I've used the fact that I can use an output here to pass this variable through so that I can put it to here. I could equally well have just dragged it off here, but I find if I'm getting long chains of functions, which I often do, then I find it easier just to make it so it's chainable. So I pass the same thing out again and pass it along the line. You could, of course, have results of calculations. One thing that's different about functions in Unreal from almost every programming language that I have seen is that you have the ability to have more than one output. And in written programming languages, I don't want to say absolutely always, but you almost always only have the ability to pass one output out from a function. So Unreal allows you to do more than one, and it's really useful. So I'm going to just restate the reason why I've used the functions here is for a little bit of tidying up. I've got 2 bits of separate functionality. I'm not actually reusing either of them, but it does mean I can look at this and go, I know I've got the control and then I've got the move. And yes, I could have done it as a big script and just used comments on here, but it just makes things tidier. So I quite like things to be tidy. The third reason why you might use functions is also it's a big reason rather than the tidiness reason. And I'm just going to go back into the pad to show you it happening, which is that you can access a function in an object from a script which is not inside that object. You can access them from different objects. Now, the bit that we've used a little bit here is actually when you see these set material nodes. These are functions, and you can tell partly because it's blue and also partly because it's got this F here at the top left. And this is one of the functions of a static mesh component, which has got a built-in function. And I'm taking the static mesh component here, cube. Remember when we were using the target for the functions before it was self? Well, we're putting in a different thing here, and we're just setting the material. So set material is a function here in the static mesh component. And in a later video, actually a series of videos, I'll be showing you how to use functions as a way of connecting things together. and getting functionality where you've got one object talking to another object and controlling what's going on. So that's as far as I want to go. We've looked at what a function is, but just to reiterate, it's a way of encapsulating some script behavior together as a little subscript. When I say little, some functions are big. It doesn't have to be little. It gives you the ability to pass input values in and output values out, and you use it for reusing code, for tidying up code, or for accessing code in one object from a different object. That's it from me for now.